Hello, everybody. So what we're doing today is we are recording the Lab 12 video. So this video is relatively long. Actually, the video, I don't know how long it'll be. The lab is relatively long because we have four problems to submit and record. Also, please notice that at the bottom, it says that you need to turn in your Java files and you need to turn in screenshots. So I'm going to actually implement all of these, I think, in one file or maybe two files, so that I can minimize the number of screenshots I need. But yeah, let's go ahead and get started. So this is going back to the week 11 material where you were learning about two-dimensional arrays like this, and also learning about methods, which is what problems 3 and 4 are about. All right, so let's get into it then. So we'll open up Eclipse, which I already have open, so I will just find it. There we go. And we will create a new Java project that I'm going to call Lab 12. And I'm going to call it part one because I think I'm going to need more than one part. And yeah, so let's do that. Let us open up, let's create a new class inside that file. I'll call that Lab 12, also part one. I'll check the box for public static void main. And there we go. So it says write a Java project called, okay, problem one, I guess. Use nested for loops to write a program that does this. So create a 2D array that has 5 rows and 4 columns. It doesn't say integers, but from looking inside here, I think integers is the right way to go. So let's do that. So int, if you're making a two-dimensional array, you put 2 sets of square brackets. Normal arrays, 1 set. Then you need a name for it. Does it tell us the name? Let's go back. It does not tell us the name. I don't see. So we'll just call it array 1. All right. And then we need it to be a new array. So new int. And we want it 5 by 4. 5 by 4. So this is how you create a 5 by 4 two-dimensional array. So 5 by 4 2D array of integers. Cool. So we did that. What's next? Use nested for loops to loop through the array and fill in these numbers. All right. And then it says use another nested for loop to print out the values. Okay. So when you're looping through the array, you need 2 for loops. So first you need a for loop that loops through the rows. So you go int I equals 0, I less than the array length, array 1 dot length, I plus plus. So that is going to loop through the rows. So that's, I'll put it maybe here, loop through rows. So that's going to be for the 5 rows. Inside of that for loop, you need a loop for the columns. And we go over this a lot more in the week, I guess, week 11, lecture 1 video, where we talk about two-dimensional arrays. But you need to start another loop counter. So I'll call this one J. The other one was called I, for int J equals 0, J less than, and instead of array 1 dot length, array 1 dot length is the number of rows. The number of columns is array 1 subscript 0 dot length, and then J plus plus. So that inner for loop, that's the one that's going to give us a counter that we're going to use for the columns. So that's the loop through columns. So you can do this for any array, and you can just replace the 0. Sorry, you can replace the array name with your array name. And if you wanted to, you could replace the 0 with an I here, and that would work the same as if we just put a 0 there. And the reason this works is because when you're doing an array, like imagine this array is array 1. then the counter I is going to be I equals 0 for the first row, I equals 1, I equals 2, I equals 3, and then I equals 4, right? And so because there's 1, 2, 3, 4, 5 rows, that is why, oops, not what I wanted. That is why the array dot one length, that's going to be 5. However, if you pull out one row, if you want to just look at one single row, the way that you would refer to this top row would be array one square bracket 0. So array one square bracket 0 is the top row. And so if you take out the top row and then do the length, then you're going to get how many entries are there in the top row, which is 4. So the array length is how many rows there are, 1, 2, 3, 4, 5. But if you take a specific row and find the length, that's going to be 1, 2, 3, 4. And I can just put a 0 here for the row because an array, a two-dimensional array has to have at least one row. So array 1, 0 will exist. Uh, and if the top row has 4 things in it, then every row has to have 4 things in it. So there's no point in changing that subscript to anything else. So with all that said, this is um, this is our code for looping through the array. Now we're supposed to do a loop that fills it in with these numbers, and we're also supposed to do a loop that prints out the values. I'm actually going to do the one that prints out the values first. So I'm going to do a system.out.println, actually just print, and in there, I don't know where I have it at, we're going to print array1 subscript I subscript j, and then after it, we're going to print a space. And if I do this, we're going to get a big long line of zeros printed out like that. So that's our entire array right now. So instead of being, 4 and then 4 and then 4 and then 4 and then 4, right? We have all these numbers. We're getting all of them printed in one row. So what we need to do to stop that from happening is after we print out all the numbers, for one row, which is the code that I've highlighted, that prints all the numbers in one row. After that for loop ends, we can do a new line. And that's just to go down to the next line. And that's going to happen once for each row. So we print out the entire row with this for loop. And then after that, we print a new line. So it'll print 4 entries, new line, 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 for the entire array. Cool. So we actually have done this already now. What we need to do is now fill in the numbers so that they're not all zeros. So I can copy this exact structure of this loop. And maybe up here, I'm going to say, hey, this is all problem 1 here. And we can delete out this stuff. And what we're supposed to do is fill in these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they're just numbers that count up. So if I go before this whole thing and I just pick a variable to be a counter, maybe I'll just call it X, and I'll just start it out at 0, which now that I think about it, I should probably put the label for problem 1 up there. So if I just start out this counter at 0, and then I do, what's it called? Array 1 subscript I subscript j. And if I just did this, that would fill in all of the entries with zeros, which is what they already are. So nothing looks any different. But if I change this number to something else like 9, now they're all 9s, right? But that's not what we want to do. What we want to do is start it at 0. Actually, no, we want to start it at 1. We want to start the X value at 1. So now we're filling them all in ones. But then what we want to do is after we fill in the entry with a particular number, let's just add 1 to the number. now it counts up from 1 to 20. Now, at that point, this is basically correct, but this is a nice square grid and this is ugly. So we might want to go and see if we can figure out how to print this better. And there is a better way to print it. The better way to print it would be to realize that the reason this is all uneven is just because that's how the print function worked. If instead of just printing it, we used printf, remember that printf has a way of reserving a certain amount of space for each character. So what I can do then, if I use printf, is that I can put a placeholder here. And so percent, we've used like things like this, like %.2f. That would mean 2 decimal places, floating point number. But another way to do it would be something like this. If I do 4, that's reserved for spaces, and then D would be for integer type numbers. So that's a weird placeholder, but we can do that. And then after that, we can put in array1 I j. And so the F in printf is formatted. So printing out formatted strings. So the formatted string I'm doing is reserving 4 spaces for a number and then filling in the number. Let's see what that looks like. Ah, perfect. So when you need to line stuff up, you often need to switch to this printf function instead of using print or print line. Or not, it's up to you. Anyway, that looks like we're done with problem 1. There was kind of some starter code here that we didn't look at. That's fine. All right, problem 2. So I'm gonna do this all here in the same thing, or at least the first 2 problems. So I'll just say problem 2. What are we doing for problem 2? Um, so we're given an array this time. So this array. So let's take it, just paste it in there. Yeah, good enough. It's not really a good way to line up that last curly brace. Sometimes I'll put it here. Doesn't really matter. All right, so we have this array called myArray, and we want to loop through the array and find the maximum and minimum values, and then afterwards print them out. So this is what it should look like at the end, because 99 is the biggest number in that array, and -5 is the smallest number in this array. So what we need to do is we need variables for those things, min and max, to start with. And when you're finding minimums and maximums, the way you start is you need to put something inside of the variable to start with. So what we put in into our array is just the first entry. So we'll start by putting the 7 in there, essentially, is what we're doing. And we'll do that for both of them. So right at this point, both the minimum and maximum are storing the value 7, which is neither the minimum nor the maximum. But we can loop through our array and now do something. So in order to loop through the array, let's just go up here to where we already have some loops looping through an array, copy one, oops, come down here, let's paste it. And this is not correct for our array because this one has the name myArray, and this one says array1 still. So let's modify our code here so that instead of array1, it's myArray. And instead of array1 here, it's myArray. And the inner for loop, the code in there is wrong. But now that we've got our loop set up, we can actually think about finding the minimum and the maximum. Now, you've done this a number of times. Most recently, we did a minimum in, I think, near the end of the week 12 lecture 1 video, but we've also done it in other places too, including the lecture for 2D arrays. So week 11 lecture 1 video covers this. But what are we doing? So in order to find a minimum, what you do is every time through the loop, we're going to be looping through these different entries. and we need to compare it to what we have as the minimum now. So we'll say if my array subscript I subscript j is less than the minimum. If it's less than the minimum, that means we just found a new minimum because we found a value smaller than the minimum. So after we check that value, if it is smaller than the minimum, we change the minimum to be equal to that thing that we just looked at, which was my array ij. And that's for the minimum. We could do an entirely new for loop for the maximum, but we don't need to. We can just do another if statement and just change it to say if my array ij is greater than the maximum, then the maximum should be my array ij. And if you do these, then what'll happen is as we loop through the array, the variables min and max will be keeping track of the biggest and the smallest values that we see. So at the end of the day, if we did this correctly, we should just be able to, after our loops are done, print out the values. So if we say the max is, and put the max, and if we do the same thing and say the min is, and we put the min, and maybe I'm even going to label it just prob 2, just so we know that this isn't for problem 1. Then we get that the max is 99 and the minimum is -5. And those are probably the correct values here. All right. So that is problem 2. So now we can move on to problem 3. Now, looking at this, we may want to start um, a new code for this. All the 2D erased can be in this project, but then I'm going to make a new Java project and we'll call this one Lab 12. I'll call it part 2, and we'll see if we can get both of these done in this project here. When I say both of them, I mean problems 1 and problems 2, but maybe not. So I'll call my class that I just created Lab 12 part 2. Check the box for public static void main, hit finish. Now we have some starting code here. I'm going to steal it for problem 3, paste it there. That's no good. Let's undo that. I say it's no good because this has a method and a method, but it does not have the class. So I need to keep the part that's the class that I just created, but I can paste my starting code inside of that. And so if I run this, where are we? What's that say? I'm gonna have to pause this in a minute. So what's happening here is there's a method up here called print stuff. And the method called print stuff needs a name and a birth year. So just to show you how it works, in main right now, if I call print stuff and I put my name and I put a birth year and I run this, it gives me my name and an age, which it calculates just by doing 2024 minus the birth year. Probably should be 2025, huh? And so you get a name and an age. And so whatever name and birth date you put in, you get the appropriate information there. Now, all you're doing in here is 3 of these, except that instead of putting my name in, right, you want to put this top name here, name 1, and you want to put the top birth year, which is birth year 1. So when I run that, it's going to be name Bolt Vanderhuge, age 70. And we want to do that for all 3 of these. That's what the instructions say. And the sample output also says that. So we just copy this 3 times. So we're just calling the same method 3 times. but for name one, birth year one, name two, birth year two, and name three, birth year three. And we run that, and that's all we're trying to print. Now, my years are going to be 1 year off here um, because I changed the date from 2024 to 2025. All right, cool. I'm going to pause this for 1 second. Hopefully, you will not see this happen. I think I paused the wrong thing. Yeah, it says screen sharing is paused. So I apologize for the delay. Let me unpause that. I was trying to pause the recording, but as soon as I walked away, I realized I did that wrong. Um, all right. So anyway, back now. Um, so we did problem 3. That's what we just did. Let's look at problem 4. Okay, problem 4 is going to need a new code. So printing out this stuff for, the names and the ages, that's all well and good. That's problem 3. But I need another project. So yet another project. I should have just done 4 since I was doing 3 anyway. But I'll call this Lab 12. I'm changing my naming scheme and I'm going prob 4. And in the source, we need a new class. I'll call it Lab 12 prob 4. Check the box. I don't know if I'll need it. And here, new problem. So what's problem 4? So they gave us this code. Again, that is the code that goes inside of the class. So I'll have to delete the main that's already there, but leave the public class part. And we get here. Now, looking at this, we should be able to read this and see what's happening in main. So in main, it's running a method called multnum 3 different times, and then it's printing um, the numbers. It's printing the numbers by calling print stuff. So if I scroll up, print stuff is right here, and looking at what print stuff does, you put in an integer and it just prints out the number. So I think print stuff looks fine. So this code in main is going to execute with no problems, but multnum is not going to run because if I look at the method called multnum, I see that there's no code in there. That's where it told us your code goes there. Now, this is really, really easy to write. It says write a user-defined function method to multiply 2 numbers and return the result. So this is really complicated, so follow along. The incoming numbers are X and Y, and we need to return them after we multiply them. So you type return X times Y. Oops. That is all the code. All right, that's all the code. So what's going to happen now when you do multnum 3, 4 is X is going to be 3, Y is going to be 4. It's going to multiply them 3 times 4 and return that. Returning it means that at the result multnum 3 comma 4, you get 12, is going to be returned right here. And so that 12 can be stored in the variable X. And multnum negative 6, 12 is going to be negative 12. And multnum 18 times negative 5 is going to be whatever 18 times negative 5 is. I think that's negative 80. But we'll find out as soon as we run this. So we just had to write this method, which was very, very short. Negative 90, that's right. I did 5 times 8 and got 30. But it's not. All right, cool. So all we had to do was finish writing that multnum, which we did, and we ran it, and it ran, and now we're done. So that's problem 4. So make sure you turn in your code for all 4 problems in however many, Java files it took you to do it. I did 3, which is dumb. I should have either done, 1 or 4 probably. 3 is unusual. So you turn in your Java files and then also screenshot the results. So you may need 1 or 2 or 3 or 4 screenshots as well. So it's kind of a lot of files, but that's what you got to submit here. Um, okay, that's it. So I'm going to stop this video here and I will talk to you guys later.